All right, continuing to talk about hypothesis testing with rejection regions. One of the pieces I forgot to mention in our previous video was when you are sketching your rejection region, how to determine what type of test you have. So if we are wanting to determine if we have a left tail, right tail, or two-tailed test, we look at the alternative hypothesis. And it's always going to be based off the alternative hypothesis. So if it is a less than symbol, we are left-tailed. If we have a greater than symbol, it's right-tailed. Or if it's not equal to, it's two-tailed. And that also corresponds with the diagrams you have on the side of table 5. So, now if we go and look at this first example, employees at a construction and mining company claim that the mean salary of the company's mechanical engineers is less than that of one of its competitors, which is $68,000. A random sample of 20 of the company's mechanical engineers has a mean salary of $66,900. Assume the population standard deviation is $5,500 and the population is normally distributed. At alpha equals 0.05, test the employee's claim. So, going through our steps, first thing we want to check is verify that sigma is known. And if we read back through here, we know that assume the population standard deviation is 5,500. And that is our sigma. So we're good there. Then we also need to check and verify that either n is greater than or equal to 30, and our n is 20, so that doesn't work. But then we can also check that our population is normally distributed, which it is. So that means our central limit theorem has been proved. So now we're going to state our claims and both of our hypotheses, the null hypothesis and the alternative hypothesis. So our claim was that the mean salary is less than $68,000. Since it's less than, that's going to be an alternative hypothesis. So mu is less than 68,000. The complement of less than is greater than or equal to, so that would be our null hypothesis. Also, I'm going to label the alternative as our claim because that will help us when we write our interpretation at the end. We want to identify alpha, and I'm also going to go ahead and label everything else that we know. So we know alpha, or our level of significance, is 0.05. We know that our sample size, n, is 20. Our sample salary mean is x bar of 66,900. And our population standard deviation, sigma, is 5,500. Okay, so now we're ready to determine the critical value and sketch our rejection region. So I'm going to start off by sketching just our normal curve. Because we have less than, this tells us that we are left-tailed. Which also tells us that our critical value will be negative. Okay, so if we go and we look at our table, let me get out of here real quick. Remember, we can always just use our t-table for this. Left-tailed here, you can see that it's going to be a negative. It's one tail, and it said alpha was 0.05. And we're just going to go to the very bottom and our critical value is going to be 1.645. So our critical value, negative 1.645. All right, so once we have that part done, we can find our standardized test statistic. I'm going to rewrite that formula. Z equals x bar minus mu divided by sigma divided by the square root of n. Same formula we used when we looked at the beginning of the normal distribution. So plugging everything in, we have 66,900 minus our mu is going to come back from our claim, so 68,000, divided by standard deviation of 5,500, divided by the square root of 20. If you plug that in your calculator, you should get approximately negative 0.89. Remember, z-scores, we always round to 2 decimal places, or the nearest hundredth. So if we put that on our number line of our normal curve, we want to see, does it fall in the shaded region or the unshaded region? So we know that negative 0.89 is bigger than negative 1.645. So this is going to fail to reject, and this is our decision. You're going to actually write it out. Fail to reject the null hypothesis. These 3 dots in the triangle is just a shorthand way of saying therefore. It is habit for me. Do not feel like you have to write it. But I do want you to always write your decision just so I can follow your mindset. Okay. All right, so writing out our interpretation. We're always going to start off by saying our level of significance, but we're going to change it to a percent. So alpha was 0.05. So as a percent, that would be 5. So we have at 5% level of significance. And the reason why that part is important is as alpha changes, that rejection region also changes. So depending on what alpha is, we could either have a different decision. So that's why it's always important to write that. So there is or is not. So because we failed to reject, that means that there is not enough evidence. And now we need to know, are we rejecting or supporting the claim? Because our claim is in our alternative hypothesis, that means that we are going to support the claim. And then you're going to rewrite that claim. So that the mean salary is less than $68,000. All right, so if we try this next one, a researcher claims that the mean annual cost of raising a child aged 2 or under by husband-wife families in the United States is $13,960. In a random sample of husband-wife families in the United States, the mean annual cost of raising a child is $13,725. The sample consists of 500 children. Assume the population standard deviation is $2,345, and at alpha equals 0.1, is there enough evidence to reject the claim? So we're going to go through our same steps. First thing we need to check, do we know the population standard deviation? And we do. We know the population standard deviation is 2,345. Then we need to check the central limit theorem. So we need to check either our sample size. Here, n is 500, so we're good to move forward. I'm just going to write that down here. As well as our population standard deviation, sigma, is 2,345. So our claim and our hypotheses. So our claim was that the mean annual cost is $13,960. Because that has equality or equal, it's going to be in our null hypothesis. And the complement of equal is not equal. Okay, I'm going to continue to write out everything else we know. So we know alpha is 0.10. And then we also know that our sample mean, X bar, is 13,725. All right, so before we find our rejection region, let's go ahead and sketch our graph. Because it is not equal to in our alternative hypothesis, that means we are two-tailed. So we're going to have two critical values, one of which is negative and one of which is positive. So alpha equals 0.1 and we're two tails. So we're going to two tails. Alpha is 0.1. Then we're going to go to the very bottom of our table 5 and we have 1.645. So our two critical values are negative 1.645 and positive 1.645. All right, so now we're going to find our standardized test statistic. So Z equals, we're going to do X bar, so 13,725 minus 13,960 divided by 2,345 divided by the square root of 500. Okay, plugging that in your calculator. And remember, we're always going to round to our nearest hundredth because we're looking at z-scores. And we should get approximately negative 2.24. Okay, if we take that back to our graph, negative 2.24 falls to the left of negative 1.645, which means that our decision is going to be reject the null hypothesis because it falls in that shaded region. Okay, so now we're going to interpret our claim. So starting off with our level of significance, alpha was 0.1, so that converts to 10%. At 10% level of significance. Okay, we rejected our null hypothesis, so that means there is enough evidence. And then we need to go back and look at our hypothesis. Our claim is in our null, which means we have enough evidence to reject the claim. That the mean annual cost is $13,960. If you're struggling with your interpretation, remember that the is based off your decision. So because we rejected, that means there is enough evidence. And then whether we reject or support is based off where your claim is at. And if you need to, go back and look at your 7-1 notes. We had that table at the end to help us with our interpretations.